Hello, let's go ahead and look at another type of application of triangles with trigonometry. And we're going to talk about something called law of sines today. But first of all, let's think about some of the things we've already covered in the past. We already know from former units that if we have a right triangle, so something like this, where we have legs with sides of A and B and a hypotenuse of side C, then if we want to find the missing side to a triangle, we know two of the sides, we can use the Pythagorean theorem, a squared plus b squared equals c squared. We can also find an angle. For example, if we wanted to find some angle of the triangle, if we know any two of the three sides, using our trig ratios, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent, and inverse trig functions. Because remember, when you talk about these types of things, what do we know when we're looking for an angle? An inverse trig function is always an angle. So we can use inverse trig functions to help us find angles. Now, not every triangle in the world is a right triangle, so that won't always work. If you have a right triangle and you have enough information to use one of these, please do it. That'll be your quickest and easiest way to deal with it. But if it's not a right triangle, what do we do? That's what we're going to be looking at in this section and the next section. If it's not a right triangle, we're either going to use something called the law of sines or the law of cosines, maybe a combination of the two. We'll see some examples. These can be useful. Today, we're going to focus on the law of sines. So when we go through and we look at these things, one of the first things that we do want to look at is which sides do we know, which angles do we know, and go from there. Let's go ahead and define law of sines. So again, that's what our focus is today. When we think about the law of sines, if you have any triangle, A, B, and C, okay, the angles are labeled with the capital letters A, B, C. We use sides with lowercase, and the sides are the opposite of their respective angle. So the opposite of angle A is side A. Opposite of angle B is side B. Opposite of angle C is side C. So if we have any of these triangles, then what we can do is use the law of sines, and what the law of sines says is that we can look at the ratios. If we take the ratio of the sine of an angle to its opposite side, so sine of angle A is to A, that ratio is going to be the same for the sine of angle B to its opposite side B, or the sine of angle C to its opposite side C. And this is one form that we can look at. You don't have to look at it with the sine of the angle in the numerator. You could also look at it as the side to the sine of the angle, as long as it's corresponding angle and side. Side to sine of the angle, side to sine of the angle, that's fine too, whichever you want to deal with. Now, just because it's what I tend to do, I tend to always just write it using this form, but either one of these are great. It really doesn't matter at all. Just remember, your numerators have to represent the same type of measure as each other when you set fractions equal, and your denominators have to represent the same type thing in your respective fractions as you go. So make sure if you start with a sine of an angle on top, then on both fractions, that's the case, okay? This will always work for any triangle. So what we want to do, let's go ahead and look at a first example here. We want to find side X for this given triangle. Now look at the information we have. Do we have a right triangle? That means that you have a 90-degree angle No. No. We have a 70 degree here, a 52 degree here. We don't have a 90 degree angle. So we're not going to use what we had before, okay? Now, law of sines. Notice what happens. Because you have fractions where you have the sine of an angle to its opposite side, the next thing you want to ask yourself is, do you have an opposite side and angle pair? Well, I'm wanting to find x, its opposite of angle 52 degrees. I have a side 26.7. It's the opposite of angle C. I don't know angle C right now. I don't know the side that's opposite angle 70. So not directly, I don't. But is it easy to get? It actually is in this case, because what do we know? For any triangle, the three angles are always going to add up to give you 180 degrees. That means if you know two of your three angles, you can get the third. So angle C is not known, but I can get it by taking 180 degrees and taking away the ones that I do know, the 52 degrees and the 70 degrees. And if I take 52 degrees and 70 degrees away from 180 degrees, I get 58 degrees. So I know this angle right here is 58 degrees. Now I have angle C is 58 degrees, and side C, because that's what's opposite of it, is 26.7. I have an opposite angle and side pair. If that's the case, then it's really nice. You can go ahead and use your law of sines, because what we know is that the sine of angle C is to C as, so that's going to be the sine of 58 degrees is to 26.7, as we're going to need another fraction on the right with an opposite angle side. We're wanting to solve for x. Notice that x is opposite of angle A, so that's side A. So I can take the sine of angle A is side A. A is 52 degrees, so the sine of 52 degrees is to x. And now we get an equation that's set up where we know 3 of the 4 parts of the two fractions that are set equal. If that's the case, then you can cross multiply. So I can cross multiply here, and I get x times the sine of 58 degrees is equal to, cross multiply here, 26.7 times the sine of 52 degrees. I want to solve for x. Since I'm multiplying by the sine of 58 degrees, I'm going to divide both sides by the sine of 58 degrees. And I have x equals. Now, I always like to be as exact as possible. So one of the things that you'll notice as I go through and tend to do these is, I'm going to type all this in. I'm not going to round until I'm done. So for example, and let me tell you what, let me pull up here just a second. This screen's being a little touchy, pardon me. Come on. Maybe it'll like me here. Here we go. All right, couple of things. Make sure your calculator, notice our angles are in degrees. Make sure your calculator is in degree mode. Notice on the screen, my calculator's in radians. So to make it a degree, I'm going to go mode. I'm going to arrow down to where it says radians and degrees. Make sure I highlight degree and press enter. Okay, so I have degrees. I can always go back to the main screen by going second mode. And now what's my calculation? It's 26.7 times, times the sine of 52 degrees, there's my numerator, divided by the sine of 58 degrees. And notice that gives me a 24.8097, and it goes on forever. So when I look at that, let me bring this back up here, so it'll take a second. This document camera always takes a second to come back when I try to expand it or make it smaller. There we go. So we got X is 24.8097. This side was to the 10th. I'm going to go ahead and round this to the 10th as well. Next digit's a 0, so I'm going to keep that as an 8. That'd be 24.8. So my answer to this is X is approximately 24.8. Now, when you're writing your answer, you want to make sure you know, are you answering an angle measure? In which case, it's either going to be degrees or radians for your units. Or a side. A side is either going to be, now if you know the units like inches or centimeters or yards or something like that, you could go ahead and say that. We don't know the units for this one, so I'm just going to write 24.8, okay? That's what we're looking at when we think about an example of law of sines. The key thing when you go through and you look at those is, do you have an opposite side and angle pair? If so, then law of sines is going to be great to go through and do the problem, okay? Let's look at a few examples here with this. Look at this guy. 123-foot support wire for a transmitting tower makes an angle of 61 degrees with the ground. The wire is to be replaced with a new wire whose angle with the ground is 46 degrees. How long should the new wire be? So we have the tower, and with the tower, first thing that we're told is that the support wire makes an angle of 61 degrees with the ground. So from the top of the tower to the ground, this wire makes a 61 degree angle with the ground. We know that that wire is 123 feet long. So that's the information we have there. Now, we're told that it's going to be replaced with a new wire whose angle with the ground is 46 degrees. So imagine if I had a new wire coming out here. If I push this out here, that makes a smaller angle. There's my 46 degree angle. This is my new wire right here. How long is the new wire? So I'm looking for this length right here, X. Well, if we look at this, a couple of things as we go, and you cannot read that 46. It does not look, it jumbled together. I'm sorry about that. That's a 46. I'll redraw that part. Notice if we focus over here on this angle that's kind of to the right, what do we have? We have an angle where one side's coming down like this, one side's coming down like this, rough shape here. You have the ground here. We know that this angle is 46 degrees. We know that this side is 123 feet, and we're looking for that there, okay? Well, notice I don't have a right triangle, so I'm not going to resort to using trig ratios like we did with triangles before. Do I have an opposite side angle pair? I actually do, because notice the 46 degree angle is opposite 123 feet. Okay, 46 degrees and 123 feet are opposite of each other. So I know I can look at a ratio. Sine of 46 degrees is to 123 feet as something else happens. Now, I'm wanting side X. Notice when I'm doing this, I have sine of an angle across the numerators. I have the opposite sides across the denominator. I'm wanting the side X. So I really need the opposite angle of side X. I don't have it, but I can get it. Because notice, if I look at my original drawing, I know I have a 61 degree here, 61 degree angle here. What's opposite of X is this angle right here, okay? Notice the 61 degrees and the angle we want is forming a straight line. They're supplemental angles. They add up to be 180 degrees. My needed angle is actually going to be 180 degrees minus 61 degrees. And if you go 180 degrees minus 61 degrees, we get 119 degrees. So I know that that angle right there is 119 degrees. So I have the sine of 119 degrees is to X using my law of sines. Sine of an angle to its opposite side is equal to sine of an angle to its opposite side. And so what can we do here? We can solve. So now that we solve, we'll cross multiply. I have X times the sine of 46 degrees equals 123 times the sine of 119 degrees. I'm multiplying by sine of 46. So I'm going to divide both sides by the sine of 46 degrees. So those cancel. So I have X equals, and again, just like the last problem, I'm going to grab the calculator and I'm going to go 123 times the sine of 119 divided by the sine of 46. Try that in your calculator. Make sure everything's set up. It's in degree mode. Make sure that you type it all in, okay? And that ends up being 149.55, goes on, okay? Well, if we look at that, I'm going to go ahead and say the new wire is about 149.6 feet long. Of course, the further you take the decimals, the better as you go. But that's your answer. That's how you go through and deal with finding a missing side using your law of sines. Okay? Let's look at another example. I should give you all a heads up as I do these videos. I am doing some of these videos from home, which means you might hear a pupper in the background every once in a while, okay? So if you hear some weird noises like just now there was a bone being chomped on, that's what it is. Let's look at a new type of thing here. Just a second. Just a second. Okay, let's look at another example here. In triangle ABC, we have angle A given as 40 degrees, side A equals 15, and side B equals 8. We want to find the missing side and the missing angles for this triangle. So sometimes it's not a specific value you're wanting. It is multiple values. You want to solve anything that's missing in the triangle. So if we look at this, we don't have the sketch given, and we really don't have to have the sketch given to use the law of sines. But a couple of things that we want to know. What is it that we're looking for? We're wanting our missing angles. The only angle we have is angle A. So we need to know what is angle B, what is angle C, and those will be the angles. We know side A and side B, so we also need side C. Those are the things that we're looking for. Do we have a right triangle? Not that we know of. Not that we know of. We're not given that we have a 90-degree angle. It's possible it could end up being a right triangle, but we don't have enough information to go with that. And remember, law of sines will work for any triangle. So our next question is, do we have an opposite angle side pair? We do. We have the angle A is 40 degrees and side A is 15. So angle A and side A are opposite angles and sides. So I can start by setting up my law of sines by going sine of A is to A, which means the sine of 40 degrees is to 15 as, and I'll need another fraction over here to get us an equation where we can solve something. Look and see if we have enough information to solve for anything else. Well, in the problem, we know that side B is 8. So if I went sine of angle B is to side B, then this will give me the equation sine of angle B is to side B is 8. I have 3 of the 4 parts of the fractions that I need in order to solve this. So I can actually go through and solve like I would have before, and we'll cross multiply. So I have 8 times the sine of 40 degrees is equal to 15 times the sine of B. Remember, we're wanting to solve for angle B, so I need to get the sine of B by itself first. I'm multiplying by 15. So I'm going to divide both sides by 15. So that gives me the sine of B is equal to 8 times the sine of 40 degrees over 15. When you have something like this, we're trying to solve for an angle. When you are going to solve for an angle, you're going to use your inverse trig functions because an inverse trig function is an angle. So B is actually the inverse sine of that fraction. B is equal to 8 times the inverse, or B is equal to the inverse sine of 8 times the sine of 40 degrees over 15. So again, we want to go through and do this. I like to be as exact as possible, so I'm going to show you 2 things you can do on the calculator for this one. And again, here we go. All right. Let's look at this one. I can type it all in at once. I can go inverse sine, and I could type in the whole fraction. I could put a fraction mode in there. I could put parentheses around the numerator and go 8 times the sine of 40 degrees. Have to close off the parenthesis of the angle 40, close off the parenthesis of the numerator, divided by the sine, or whoops, nope, sorry, it was not the sine. It was just divided by 15. I was thinking about the last problem. So there's the inverse sine of the whole thing, and that gives us 20.048. It goes on. Notice you can do it in parts too. You could go, what's inside? 8 times the sine of 40 degrees divided by 15. So that gives you the part that's inside the inverse sine. And the trick for this, anytime you want to do something to a number that's in your calculator and not have to round, you can go inverse sine, so second sine brings up inverse sine, and we want that last thing that was in there. If you hit the second button and that little negative that's at the bottom beside the enter key, it's going to pull up ANS. That's the last answer that was in your calculator. Okay. And you get the inverse sine of that value is 20.048. Same thing that we got before. Notice if I had gone inverse sine with these calculators, this is a TI-84, I can actually arrow up to a value that I want. I want the inverse sine of that number. I can arrow up till it's highlighted and press enter, and it'll stick that whole thing in. And I get the same thing. So lots of different ways that you can enter your values and get your answers, okay? But that's how you can do it without having to round. You always want to be as exact as possible. Think about this. A lot of you all may be going into some types of computer science or engineering or something like that. And if you're going into engineering, you definitely want to be as exact as possible in your values. So we know from here, now that I'm done, angle B is approximately, I'll go to the 10th. My next digit's a 4, so I'm going to round down. That's 20.0 degrees. So I know angle B is approximately 20.0 degrees. I have that value, okay? So I have angle A, I know angle B. Anytime you know 2 angles, you can find the third angle, because what do we know about 3 angles of a triangle? They always add up to 180 degrees. So that means that angle C is going to be 180 degrees minus the measure of angle B minus the measure of angle A. That's 180 degrees minus 20.0 degrees minus 40.0 degrees or 40 degrees. And that is 120.0 degrees. So we know angle C. Okay, so we have that. Now, side C, I'm actually not finished. This is not my final answer, and I'm going to explain this in just a second. But for this situation, I can get C because with C, now I have angle C. I'm looking for side C. I knew angle A and B. So I can go the sine of 40 degrees, that's A, is to side A, 15, as the sine of 120 degrees, which is C, is to side C. And I can use the law of sines again. So I'm having to use the law of sines a second time, and I cross multiply. So I get C times the sine of 40 degrees equals 15 times, I'm running out of room, sorry, sine of 15 times sine of 120 degrees. If you solve for that, we get C is 20.209. It goes on. So C is approximately 20.2. Okay. So we have these answers. Now here's the thing. There's a trick to this one. Okay. It's not really a trick, but there's an important thing to note with these. Anytime, and I'm going to stress, anytime, okay, you use the law of sines to find an angle first. Anytime, the first thing you do is use the law of sines to find an angle. You have to look at two possible cases, okay? The first case is going to be what followed directly. We used the law of sines. We got angle B was approximately 20.0 degrees. That's case one. And we continued and found that angle C was approximately 120.0 degrees and side C was approximately 20.2. So we got that solution, okay? We have to look at a possible case two, okay? What you do with this is there are actually two possibilities for angle B. It can be 20 itself, or it can be, take the supplement of angle B. Angle B could also be 180 degrees minus that 20.0 we found, which is 160.0 degrees. It may lead to a solution and it may not. I'll kind of look at a graph to show you the reason, but we look at this. But we have to look at this case. So if angle B is 160, remember how we got angle C? We got it by taking 180 degrees minus angle B, minus, so this was B, minus angle A was 40 degrees. Notice if I do this, I get a negative 20 degrees. A negative, that's not possible. So for this problem, case two does not work. This is our only solution. Anytime you use the law of sines to find the angle first, you're either going to get no solution at all, exactly one solution, or you might actually get two solutions. And you'll see some examples today where we do have a couple of solutions. Let's think about a situation. I guess one way to think about this graphically, the reason why, I'm going to kind of fit it in up here in the corner. We have that angle A is 40 degrees. So we could have a 40-degree angle right here. Okay. We could have a 40-degree angle right here where We have this, maybe a triangle like this. The opposite side of 40 is the 15, okay? Or we could actually have angle A being, let me imagine if I stretch this up here, an opposite angle of 15. We could actually have this type situation where we have a 40-degree angle here. So A could be here or here. So this angle B here in this triangle that's on the lower part is opposite of side B, which is 8. That angle B is acute, for example, the 20 degrees. Or we could have this situation up here where this is angle B, and we really have this shape. We still have the 15 opposite the 40 and the opposite side of 8. Now, graphically looking at it, which case makes more sense, right? And that would be the supplement, which is 160 degrees. Now remember, we found in this one that the second solution didn't work. And one of the reasons why, look at this, remember with triangles, your smallest side is going to be opposite the smallest angle. Your largest side is going to be opposite the largest angle. 20 degrees is smaller than 40. 8 is shorter than 15. 120 degrees is a lot bigger than 40, but notice that side would have been a lot bigger. But that's just a quick graph to look at. It is possible to have more than one solution. Remember that. If you use the law of sines, make sure to find an angle. Make sure you look at two possibilities. Okay? Let's go ahead and look at another example here. All right, let's look at this guy. We want to find angle theta. Now, angle theta, again, we're trying to find an angle. Let's look at the information we're given. If we think about a few things here, do we have a right triangle? Nope. In all these examples I'm looking at, I'm not going to have a right triangle with these, so because we would just do it like we did in previous sections. Do we have an opposite angle side pair? Well, we do. We have this 120 degree here, which is opposite of 45. So we do have an opposite angle side pair. So we can think of law of sines and have sine of 120 degrees is to 45 as something. We're looking for angle theta. Do we know anything about the opposite side of theta? It's 36. So theta is angle C, which is the opposite of 36. So what we have is the sine of theta is to the opposite side of theta, which is 36. So notice our setup. Using our law of sines, what did I do? I had sine of A is to A as sine of C was to C. Okay, I used the law of sines. So I can go through and solve this, cross multiply. That's 36 times the sine of 120 degrees equals 45 times the sine of theta. Divide both sides by 45. Those cancel. So we have the sine of theta is equal to 36 sine of 120 degrees over 45. What's that mean about angle theta? Theta is going to be the inverse sine of that fraction. Okay. So when we go through and find that, again, our angles are in degrees. Make sure your calculator is in degree mode and go through and evaluate. So if we go through and we look at this, this gives us 43.853 goes on. So that tells me that theta is approximately 43.8 degrees. If it's an angle, it needs to be in either degrees or radians. If it's degrees, don't forget your little bubble symbol, your little degree symbol there. Now, I did use law of sines to find an angle. So what did we just say? Two possible cases. Now, first of all, we were given this triangle. It's really clear that theta, based on this triangle, is an acute angle. It's a small angle. It's under 90 degrees. This fits acute angle. Our second case, if we followed our case, would be that theta would be approximately 180 degrees minus 43.8. And that is 136.2 degrees. That's definitely not acute. That's a huge angle. So that's not going to work. But also you could look at it like this. You know the 120. You can make sure, because what that would mean would be angle B would be 180 degrees minus angle A minus angle C, which would be minus angle A is 120 degrees. In this case, angle C would be 136.2 degrees. That's going to be a negative number. Can't happen. For this problem, there's only one answer. Theta is approximately 43.8 degrees, okay? We will see cases, I promise you, where they are a little bit, oops, nope, sugar. Look at this. Next digit, if I'm rounding, that next digit is 5 or larger. This should actually round up to a 9. It's approximately 43.9 degrees. If your next digit is 5 or larger, round up. Okay. All right. Let's keep moving on here. Next example. We're given a triangle, ABC. Angle A is 40 degrees. Side A is 15. Side B is 20. Similar to one that we looked at earlier. So we want to find the missing angles on the sides. So what do we want for our answer? We know angle A, so we need angle B. We need angle C. We know side A and B, so we need side C. So we want to look at those cases. Do we have an opposite side angle pair? We do. We know angle A and side A. So we know that we have the sine of 40 degrees is to 15 for our A's, okay? And can we use the law of sines with the sine of another angle to a side? Well, we know that side B is 20. So if side B is 20, then this would be the sine of angle B. So we can find angle B using our law of sines. Again, we'll cross multiply. So that's going to be 20 times the sine of 40 degrees is equal to, cross multiply, 15 times the sine of B. We're solving for B, so let's work down to it. Divide both sides by 15. Notice there are times you can simplify. For example, 20 and 15 are factors that will simplify, but we're going to end up using our calculator anyway. I'm not going to bother. I'm going to go ahead. So this means that we have the sine of B is equal to 20 times the sine of 40 degrees over 15. And what's that mean? If we want to find angle B, we use inverse sine. That's the same thing as saying B is equal to the inverse sine of that fraction. Okay, so again, we're going to grab our calculators and calculate the inverse sine of 20 times the sine of 40 divided by 15. And we get 58.986, so on. So that tells us that angle B is approximately, this is an angle, if I round to the 10th, the next digit's bigger than 5, that's going to round up. This rounds up to be 59.0 degrees. But again, what did I do? So the first thing I did was find an angle with the law of sines. So I need two cases. This is the only time with these guys that we're going to do two cases, okay? So I'm going to look at case 1. Case 1 is the guy that we have right here. Angle B is approximately 59.0 degrees. That means for case 2, angle B is going to be approximately the supplement of that, 180 minus 59, which is 121.0 degrees. So I have those two cases. So I know that much. Let's see what that means for angle C. For this case, angle C would be 180 degrees minus angle B minus our angle A that we were given. So 180 minus the 59 minus the 40 gives us 81 degrees. So that worked. Case 2, angle C would be 180 degrees minus angle B minus angle A that we were given. So we have 180 minus 121 minus 40. That's 19 degrees. That's okay. Both of these cases work. Both of these cases give us all positive angles. So we have something for angle B, something for angle C in both cases, okay? So what do we have left? We need to figure out what side C is. So for each case, we're going to figure out side C, and we can use our law of sines again. We have our A's. So the sine of angle A is sine of 40 degrees is the side A, which was 15, as the sine of angle C would be 81 degrees is to side C. And so again, we would use our law of sines. So we have C times the sine of 40 degrees equals 15 times the sine of 81 degrees. Divide by sine of 40. Again, make sure your calculator's in the right mode, right? So we have 15 times the sine of 81 degrees divided by the sine of 40 degrees. And that gives us a 23.048, so on. If I went to the 10th, that would be approximately 23.0, okay? Do the exact same thing over here. Sine of 40 degrees is to 15, as the sine of angle C is to side C. Cross multiply. Divide by sine of 40 degrees. So we have 15 times the sine of 19 degrees divided by the sine of 40 degrees. And we get C is 7.597 to the 10th. That's going to round up to be about 7.6. So we actually have two solutions for this. One of our solutions, excuse me, angle B is approximately 59 degrees. Angle C was 81 degrees. And I did round, so I'm using the approximate. And side C was 23.0. That's one solution. But we actually have another solution here. Angle B could also be 121 degrees. Angle C could be 19 degrees. And side C approximately 7.6. So we actually have two solutions in this case. Again, it is possible that you have no solution to a triangle, only one solution like the last couple of examples, or two solutions, as in this one, okay? So make sure you look for two cases, and that's a second case there. Let's do one more example in this video here, and we'll pause. A word problem, an application. From the top of an office building that is 72 feet high, the angle of elevation to the building across the street is 31 degrees. From the bottom of the office building, the angle of elevation to the top of the building across the street is 46 degrees. How high is the building across the street? So if we look what's happening here, and we're doing a lot of assumptions here. We're assuming that the ground's even. So we have the ground here. So we have one building over here. Okay. This is our office building. We know it's 72 feet high. Okay. And it says its angle of elevation to the building across the street is 31 degrees. So remember what angle of elevation is. The angle of elevation to the building across the street from the top of the office building. Angle of elevation goes up by 31 degrees. So our 31 degrees is right here. That's really telling us that this building across the street is taller because we're having to go up to it. Okay. So we have that angle is 31. From the bottom of the office building, the angle of elevation to the top across the street is 46 degrees. From the bottom of the office to the top of the building across the street, the angle of elevation is 46 degrees. And we want to know how high is the building across the street. So we're looking for this height right here. Okay. Well, let's look at the information that we're given. We want to be able to get to this side over here. Now, if we notice down here, we have a nice right triangle right here. And we have a right triangle, we have an angle, we have a side, but we really can't use trig ratios for this unless we know the side here, which is the hypotenuse of this guy, or the side down here, which is the adjacent side, or not the adjacent. Yeah, that's the adjacent side of the 46 degrees. We need one of those sides in order to use our trig ratios. We don't have enough information there to do that. But notice up here, we have another triangle where we could actually get enough information to go. Let's look at this one that I kind of did in green here. I'm going to break it up here for a second, okay? So this upper triangle, I know that this angle right here was 31 degrees. Notice this with the horizontal is 90. So this angle here is made up of the 90 degree and the 31 degree, which is 121 degrees. So we get 121 degrees right there. We know that this angle is 46 degrees. Okay. So that means this angle is going to be 90 minus 46. That's going to be 44 degrees. And we know this side, because that's 72 feet. Notice this side right here is the hypotenuse of the angle below. So if I could find this guy, I'm going to call it H because it's the hypotenuse of this lower angle, then I'd be in good shape to use ratios from the angle that's lower. Well, I have enough. I know that sine of 121 degrees is to H as, here's a side that's 72. If I knew its opposite angle, and I can get that because I have 44 degrees here and 121 degrees here, so I can get that angle that's opposite because all three angles always add up to 180. So if I go 180 minus 121 minus 44, so 180 minus 121 minus 44 gives me 15 degrees. So that would be the sine of 15 degrees is 72. I can use my law of sines. Cross multiply, H times the sine of 15 degrees is to 72 times the sine of 121 degrees, divided by the sine of 15 degrees. So that side H is approximately, so I have 72 times the sine of 121 degrees divided by the sine of 15. That is that's 238.452, etc. So that hypotenuse is approximately 238.5 feet. Now here's the thing. What that means is in that lower triangle, it's actually a right triangle. Okay. I know this angle is 46 degrees. I know I'm looking for side X. Okay. And I just found that this hypotenuse is 238.452. It goes on forever. Like I've said earlier, I like to be as exact as possible. So I'm going to use this number. Sorry, I was trying to get it clear for you. I am going to keep that number as exact as possible till the end, because thankfully with technology, I can be a lot more exact with my calculations in the calculator, and I'll show it to you there. We have a right triangle. Notice for this 46-degree angle, the X is the opposite side, and the 238 point blah, blah, blah is the hypotenuse. Think about your trig functions with right triangles, your trig ratios. Which trig function involved opposite and hypotenuse? It was sine. The sine of any angle is equal to the opposite over the hypotenuse. So the sine of 46 degrees is equal to the opposite side of X divided by the hypotenuse. So I can undo the division by multiplying both sides. So that tells me that X is equal to that 238.45 number times the sine of 46 degrees. Well, here's the thing with this one, and I'm going to go ahead and pull up the calculator with this guy too. Okay. Let me see if it will pull up for me. There it goes. All right. So notice what I had done before. I had gone 72 times the sine of 121 divided by the sine of 15. This is the calculation that I did a minute ago to find that side H, or the hypotenuse. 238.452. That's in my calculator. So now, what was I wanting to do to get X? I was wanting to take this number and multiply it by the sine of 46. So that's in my calculator. I can just go times, and it's going to pull up that full value, sine of 46, and I get 171.528, so on. I try not to round until the very end of a problem. Now, if I had gone 72 times 238, whoops, sorry, 72, that's not what I wanted there. Nope. Sorry. I wanted the number 238. 238 times the sine of 46. That's what I had. I went back to an old problem. 238 times the sine of 46. Notice I get 171.2. My exact answer was 171.5, so on. You get a little bit off. The further you round, the further. If I'd gone 238.5 times sine of 46, the further I take the number, the closer to the exact answer I'm going to get, okay? So be careful when you go in. Try not to round to the end of a problem until you have that final answer. So for this problem, and I'm trying to get it to blow back up. Here we go. So for this problem, the building across the street is approximately 171.5 feet tall. Okay. And there's our answer. So again, we can use law of sines. Sometimes you can pull in your trig ratios and it would help. If you have an application problem, lots of times a sketch will really help you see what's going on. Okay. go ahead and try some of your homework. In your notes, you have some problems that say try. I'm going to do a separate video that I just worked through. You have the answers. Try those, check yourself, and then if you are struggling with it, go ahead and check out the video that says the try problems for law of sines, okay? Thank you all, and we'll yell if you have any questions.